In this video, we're going to focus on ellipses. We're going to talk about how to graph an ellipse and also how to find the coordinates of the vertices and the foci of the ellipse. So let's begin. On the left, we have an ellipse with a horizontal major axis. On the right, the major axis is vertical. The length of the major axis is always equal to 2a. And that's the case for both types of ellipses. This is the length of the minor axis, which is vertical on the left, but it's horizontal on the right. The length of the minor axis, it's equal to 2b. For this one, the minor axis is horizontal, but it's still equal to 2b. Now, whenever you have an ellipse where it's centered at the origin, here's the equations that you're going to be dealing with. For a horizontal ellipse, it's x squared over a squared plus y squared over b squared. For the ellipse on the right, it's x squared over b squared plus y squared over a squared equals 1. Now, to determine which type of ellipse that you have, whether it's elongated in the x direction or elongated in the y direction, look at your a value. A is always bigger than b when dealing with ellipses. If the larger number is under x squared, you're dealing with an ellipse with a horizontal major axis. If the larger number a is under y squared, then the ellipse is vertical. It has a major vertical axis. So let's say this is the center. This is going to be positive a, or just a, and this is negative a, this is b, and this is negative b. So here are the major vertices, and these 2 points represent the minor vertices. For the graph on the right, here are the major vertices, and here are the minor vertices. For the ellipse on the left, the coordinates of the major vertices are plus or minus a comma 0. For the minor vertices, it's 0 plus or minus b. For the ellipse on the right, it's the reverse. The coordinates of the major vertices are 0 comma plus or minus b, and for the minor vertices, it's plus or minus a comma 0. Now let's talk about the coordinates of the foci. For the ellipse on the left, the foci will be along the major horizontal axis, and it's c units away from the origin or the center. So once you have the center, if you add c, you'll get the focus on the right. If you subtract it by c, you'll get the focus on the left. So the coordinates for the foci is going to be plus or minus c comma 0 for the ellipse on the left side. For the ellipse on the right side, it's 0 plus or minus c. So starting from the center, you need to go up c units and down c units. And that will give you the coordinates of the foci. Now, what happens if we have an ellipse that is not centered at the origin? If it's not centered at the origin, then the coordinates of the center become h comma k. This equation changes to x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the same is true for this equation. Everything will be the same, but we're going to replace x with x minus h squared. And this will be over b squared. And then we're going to replace y with y minus k squared. And this will be over a squared. Now let's focus our attention on the horizontal ellipse. When the center is the origin, I mentioned that the coordinates of the foci is plus or minus c, comma 0. But now when the center is shifted to some point h, comma k, the coordinates of the foci, or rather the foci, will be shifted. So all you need to do is add the coordinates of the center to the coordinates of the foci. So we're going to add plus or minus c to h. So it's going to be h plus or minus c, and then we're going to add k to 0, which will be k. So this will be the new coordinates of the foci for horizontal ellipse. Now the coordinates of the vertices are plus or minus a, comma 0, and 0 plus or minus b. So when it's shifted, all you got to do is add the coordinates of the center to the vertices to get the new one. So to get the major vertices, it's going to be h plus or minus a, comma k, and for the minor vertices, it's going to be h, comma k plus or minus b. Now let's consider the situation if we have a vertical ellipse. As the center shifts from the origin to some point h, comma k, let's see what's going to happen to the foci. So the coordinates of the foci, if the center is at the origin, is 0 plus or minus c. When the graph has shifted from the origin, it's going to be h, comma k plus or minus c. The major vertices will be 0 plus or minus a. The minor vertices is plus or minus b, comma 0. So when it's been shifted, this becomes h, comma k plus or minus a, and this becomes h plus or minus b, comma k. Now let's work on some practice problems. Go ahead and graph the ellipse and identify the coordinates of the vertices and the foci. By the way, in order to find the foci, you need to know how to calculate c. And here is the equation to calculate c. It's a squared minus b squared. Well, c squared is a squared minus b squared, not a squared plus b squared as in the case of the Pythagorean theorem. For hyperbolas, it's c squared equals a squared plus b squared. But for ellipses, c squared is equal to a squared minus b squared. So that's how you can calculate c, using that formula. So feel free to try this problem. In this problem, there's no h or k value. So the coordinates of the center is 0, comma 0. A squared is going to be the larger of the two numbers. So 9 is greater than 4. That means a squared is 9, which means a is the square root of 9. So a is 3. B squared is the other number, 4, which means b is the square root of 4, or 2. So now that we know the values of a and b and the center, we can go ahead and graph the ellipse. So first, let's plot the center. A is under the x variable, so we're going to travel 3 units to the right from the center along the x-axis and 3 units to the left. So this gives us the coordinates of the major vertices, which is going to be plus or minus a, comma 0, or plus or minus 3, comma 0. Now b is 2, and b, or b squared, is under y squared. So we're going to go up 2 units from the center along the y-axis and down 2 units. So this gives us the coordinates of the minor vertices, which is 0 plus or minus b, or 0 plus or minus 2. So those are the coordinates of the vertices of the ellipse. Now we can go ahead and graph the ellipse by connecting these 4 vertices together. So that's how you can graph an ellipse. Now how can we find the coordinates of the foci? So the coordinates of the foci is going to be plus or minus c comma 0. It's going to be along the major horizontal axis for this problem. So since A is along the x-axis, the foci will be along the x-axis as well. So we need to determine c. We know that c squared is a squared minus b squared. A squared is 9, b squared is 4. 9 minus 4 is 5. Taking the square root of both sides, we get that c is equal to plus or minus the square root of 5. So the coordinates of the foci will be plus or minus root 5 comma 0. If you have your calculator and you type in the square root of 5, the square root of 5 is 2.236 approximately. So along the x-axis, that's going to be somewhere in this region. So that's how we can plot the coordinates of the foci for this problem. Now let's try a similar problem to the last one. So for the sake of practice, feel free to pause the video and work on this example problem. Go ahead and graph the ellipse and then find the coordinates of the vertices and the foci. So the first thing we should do is identify the coordinates of the center. There's no h or k for this problem, so the center is going to be the origin. It's 0, 0. Next, we need to determine our a squared value. Is it 9 or is it 16? A squared will be the larger of the two numbers. 16 is greater than 9, so a squared is 16. So once we have a squared, we need to calculate a. A is going to be the square root of 16, which is 4. B squared has to be the other number, 9. Thus b is going to be the square root of 9, which is 3. So now that we have a and b, we can go ahead and graph the ellipse. So b is 3, and b squared is associated with the x variable. It's under x squared. So what we're going to do is we're going to travel 3 units to the right from the center and 3 units to the left from the center. So this is going to give us not the major vertices, but the minor vertices. The minor vertices is always associated with b. So the coordinates of the minor vertices for this problem is plus or minus b comma 0. So that's plus or minus 3 comma 0. Now a is 4 and it's associated with y. A squared is under y squared, so a is going to be along the y-axis. So we're going to travel 4 units from the center and 4 units below the center. So the coordinates of the major vertices will be 0, 4 and 0, -4. And here's the center. So it's 0 plus or minus a, or 0 plus or minus 0, plus or minus 4. So now let's go ahead and graph the ellipse. So that's how we can plot it. Now the last thing we need to do is find the coordinates of the foci. So because the major horizontal axis is the y-axis in this case, the foci will be along that major vertical axis. But first we need to calculate c. Let's use this formula. C squared is equal to a squared minus b squared. A squared is 16, b squared is 9. 16 minus 9 is 7. So c is going to be plus or minus square root 7. Now the square root of 7, it's about 2.6. So the coordinates of the foci will be in this region. It's in the same direction as plus or minus a, which is along the y-axis. Now the coordinates of the foci in this problem is going to be 0, comma, plus or minus c, or 0, comma, plus or minus the square root of 7. So that's how you could find the coordinates of the foci, as well as the coordinates of the vertices. Number 3, identify the coordinates of the center, vertices, and foci, and then graph the ellipse. So the center is going to be h, comma, k. Here we have x minus 3. H is simply going to be 3. You just need to change the sign. Here we have y plus 2, so k is going to be negative 2. So that's h and k in this problem. So now that we have the coordinates of the center, let's determine our a and b values. So which one is going to be a squared, 16 or 25? Well, 25 is larger than 16, so a squared will be 25. A is going to be the square root of 25, which is 5. B squared is the other number, 16, so B is going to be 4. Now let's go ahead and graph it. So first, let's plot the center, which is 3, negative 2. So we're going to travel 3 units to the right, and we're going to travel down 2 units. So there is the center. Now, a is 5, and a is associated with the y variable. So from the center, we're going to go up 5 units. Right now, we're at a y value of negative 2, so we're going to stop at 3. And then we're going to go down 5 units. And so the coordinates of the vertices, rather than being 0, comma, plus or minus a, it's h, comma, k, plus or minus a. H is 3, k is negative 2, a is 5. Negative 2 plus 5 is 3, and negative 2 minus 5 is negative 7. So here, this point is at 3, comma 3, and this point here is 3 and negative 7. So those are the coordinates of the major vertices. Now, let's focus on B. B is 4, and it's associated with the x variable, so we're going to go 4 units to the left and 4 units to the right, starting from the center. So let's go 4 units to the right. So we get this point here, and then 4 units to the left will take us to this point. So the coordinates of the minor vertices, rather than being plus or minus b, comma 0, it's going to be h plus or minus b, comma k. H is 3, b is 4, k is negative 2. 3 plus 4 is 7, and 3 minus 4 is negative 1. So this point here, that's 7, negative 2, and then this other one is negative 1, negative 2. So now let's go ahead and graph the ellipse. So that's how we can graph this particular ellipse. And we have the coordinates of the major and minor vertices. Now, let's focus on finding the coordinates of the foci. So the major axis the major axis is vertical. Thus, the coordinates of the foci will be along that line. So rather than being 0, comma, plus or minus c, it's going to be h comma k plus or minus c. So let's begin by finding c. C squared is going to be a squared minus b squared. A squared is 25, b squared is 16. 25 minus 16 is 9. The square root of 9 is 3. So c is going to be plus or minus 3. By the way, technically, a is plus or minus 5, and b is plus or minus 4. Because to get the coordinates of the vertices, we would have to add 5 and subtract 5 from the center. So it's technically more accurate to say plus or minus 4 and plus or minus 5 for a and b. So now that we have the value of c, we said that c is plus or minus 3. Let's use this to find the coordinates of the foci. So h is 3, k is negative 2, and we're going to add plus or minus 3 to that. Negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. So we have a focus at 3, 1, which is here, and we have another one at 3, negative 5, which is here. So technically what we need to do is, starting from the center, we would go up c units, or up 3 units, to get this point, 3, 1, and then we would travel down 3 units to get the other focus, which is 3, negative 5. Number 4, identify the coordinates of the center, vertices, and foci. And then we'll graph the ellipse. So let's begin with the center. So here we have a negative 1 in front of x. We're going to change it to positive 1. And here we have a positive 1 in front of y. So this will become negative 1. So the center is at 1, negative 1. A squared is going to be the larger of the two numbers. So a squared is 9. A is going to be the square root of 9, which is 3. If you want to write plus or minus 3, that's up to you, but if you just put 3, you can still graph it correctly, and you'll still get the correct coordinates. B squared, that's going to be 4. The square root of 4 is 2. Now let's go ahead and calculate C. So C squared is A squared minus B squared. A squared is 9, B squared is 4. So C squared is 5. The C is going to be the square root of 5. And you could write that as plus or minus root 5 if you want to. Now let's go ahead and graph the ellipse. Let's first put the appropriate markings on the x and y axis. So the center is at 1, negative 1, which is here. A is 3, and A is associated with the x variable. So we're going to travel 3 units to the right and 3 units to the left. B is 2, and it's b squared is under y squared. So we're going to go up 2, parallel to the y-axis, and then down 2. So that's how we can graph the ellipse in this problem. Now let's identify the coordinates of the vertices. If you ever forget the formula, you can just look at your graph. So here we can see that it's 4, negative 1, and here the x value is negative 2 with the y value is negative 1. So it's negative 2, 1. And if you remember the formula, it's h plus or minus a, k for a horizontal ellipse. H is 1, a is 3, k is negative 1. So you get 1 plus 3, which is 4, and 1 minus 3, which is negative 2. And this should be negative 2, negative 1. So those are the ways in which you can find the vertices of the ellipse. Now let's find the minor vertices of the ellipse. So this point here has an x and y value of 1, and this point here has an x value of 1 but a y value of -3. Or you could use this formula. It's h plus or minus b. Actually, I take that back. It's h comma k plus or minus b. So h is 1, k is -1, b is 2. So it's -1 plus 2, which is 1, and then it's -1 minus 2, which is -3, giving us those two minor vertices. I want you to be familiar with this formula because sometimes a or b could be a radical value. And to get the right answer, you need to use that formula, as will be the case of the foci in this example. So the coordinates of the foci for horizontal ellipse is going to be h plus or minus c comma k. H is 1, c is the square root of 5, so it's going to be 1 plus or minus √5 comma k. In this case, we can't simplify the coordinates of the foci. So we have to leave it like this. So that's our answer for the coordinates of the foci. So starting from the center, we would have to travel c units to the right. The square root of 5 is like 2.2 something, 2.236. So going a little bit more than 2 to the right would take us somewhere to this point, and a little bit more than 2 to the left would take us to that point. So that's approximately where the two focal points will be. But this is what you would report as your answer for the coordinates of the foci. So anytime you have a radical, it's going to be hard to identify the points using the graph. You need to use this expression. So that's why I want you to learn how to use it, because you're going to need it for some problems. Number 5. Write the standard form of the equation for the ellipse shown below. So first, we need to realize that the center is at the origin. And this is a horizontal ellipse, where we have a horizontal major axis. So a squared is going to be under x squared. So this is the general formula of the equation that we need to use. X squared over a squared plus y squared over b squared is equal to 1. So if we could find the values of a and b, we could write the equation in standard form. A is 4, because this point here, the major vertices, is 4 units away from the center. We can see that b is 2. The minor vertices are 2 units away from the center. So if a is 4, that means that a squared is 4 squared, which is 16. And if b is 2, b squared, or 2 squared, is 4. So the formula that we have is x squared over 16 squared plus y squared over 4 squared is equal to 1. So this is the answer for this problem. Number 6. Write the standard form of the equation for the ellipse shown below. So we're given the center of the ellipse, which is -3, 2. And we could find a and b. So the distance between the center and one of the vertices, we could see it's 1, 2, 3, 4, 5 units. So it's 5 units along the x direction, and along the y direction, it's 1, 2, 3. Let me use a different color to count. So this is 1, 2, 3, 4. So we went down 4 units to get one of the minor vertices. So a is going to be the bigger number. That means a is 5, b is 4. If a is 5, a squared is going to be 25, b squared is 16. So now that we have the values of a squared and b squared, and we have c, our center, we can write the standard form of the equation. So a is horizontal. So what we have is a horizontal ellipse, or an ellipse with a horizontal major axis. So the formula we're going to use is x minus h squared over a squared, since a is parallel to the x-axis, plus y minus k squared over b squared is equal to 1. H is negative 3, k is 2. So this is going to be x minus h. Let's use brackets for now. H is negative 3. A squared is 25. And then y minus k is positive 2. B squared is 16. So this becomes x plus 3. So we change negative 3 to positive 3. Squared over 25 plus y minus 2 squared over 16 is equal to 1. So that's how we can convert from the graph to the equation in standard form.